All right. Hello. Welcome to the last meetup of 2016 for DigitalOcean NYC community. Just by a show of hands, who here is it their first time at one of our meetups? Awesome. Great. Thanks for coming. So for those that are unfamiliar with DigitalOcean, we are a cloud computing platform. You can use us to seamlessly manage your infrastructure for hosting your websites, your applications, and any various projects. We have a little credit here for $15. So if you haven't used us before, please give us a try with just DigitalOceanRedis 15. So today, we're going to be talking about Redis Labs. The first speaker we have is Ben Schaechter, who is a product manager here at DigitalOcean, and he's going to be talking about how to get started with Redis on DigitalOcean, and then followed by him, we'll have Madhu, who is with Redis Labs, and he's going to be talking more about Redis Labs as a whole. And then at the end of the presentation, we're going to be doing fun raffle prize drawing. We have 7 different prizes to give away from ThinkGeek. So super cool prizes. If you don't have your raffle ticket, come find me. If you didn't get one, I'll get you one. But yeah, let's get Ben started.
Cool. Awesome. Sweet. So, hey, I'm Ben Schaechter. I'm a product manager here. I work on the Droplet and block storage products. So actually, those are the 2 main products that are out there. There's also networking insights and a few other things that are going to be launching soon. But maybe just to start, show of hands, raise your hand if you've used DigitalOcean before. OK, great. Hands down. And then raise your hand if you've used Redis. OK, and then of the people who raise their hands, you can just shout out, what are you doing with Redis right now? Like, what are the use cases? Cache layer. What else?
We put ours in front of a CMS.
In front of a CMS for like, what?
We make the CMS and then distribute it. So we ship with either Redis or Memcached the environment they want to set up.
Sweet. What else? I saw some hands over here. OK. Cool. All right. So there's like a variety of use cases that you can use Redis for. I, in the past, have used it for like pub/sub type stuff as well. A whole bunch of like caching things, search indexes, everything like that. So all I'm going to do real quick is just show how easy it is to get started like using Redis on top of DigitalOcean. So this may be like fairly elementary, but I thought it'd be good just to kind of go for the people. I know we have kind of a large spectrum of usage from people who have maybe never used Redis or DigitalOcean before, to people who are like doing very advanced stuff. So I'm just going to run through like how to create a droplet. And has anyone heard about like one-click applications on top of DigitalOcean? They know it, yeah? So DigitalOcean, we've actually gone through and curated a whole bunch of one-click apps, which basically will fire up a Droplet VM and install that set of software configured for you. And Redis is one of those one-click applications that we have. So yeah, let's go through what that looks like just with Redis right now. So we can just kind of mess around with it. I can show people who are unfamiliar with DigitalOcean how simple this is. So you can go ahead and create a VM. We typically just allow you to choose like a distribution, but there's also this set of one-click applications. All of them are on Ubuntu. You can come down. You can select a size. We have different classes. We actually just launched an additional class of pricing plans. So Redis is something that's typically bound by RAM or memory, and so it's actually well suited for like high memory type instances where the price point per gigabyte of RAM is cheaper than our standard plans. So for our standard plans, you're paying $10 per gigabyte of RAM per month. High memory have a different balance of resources, so you're actually only paying $7.50 per gigabyte per month. So there's well suited for larger applications. You can see they start at like 120 bucks, which is probably pretty crazy for the vast majority of individual developers. But for the purposes of this demo, we'll just go ahead and do a high memory plan for fun. Enable private networking, get going. So all this is doing is we're firing up a droplet. It's being configured. One product improvement that we're working on right now is currently we just email you like SSH instructions. Like I didn't do anything with SSH keys. The root password you'll all see in my email, but that's fine. We won't focus on that. And then once this is done being built, I'll go ahead and SSH in and kind of fire up, see that Redis is running. It'll give you some instructions. I'll install Ruby, and we can kind of mess around with it there. OK. So let's see here. Give it a second to shoot me the, I probably should have just used SSH keys. Droplet has been created twice. That's good. Let's see if it actually just got caught in my, yeah. All right, well, we can try and actually just, let's give it one more second. There we go. All right, so we've got this new droplet here. Let's SSH into it. Whoops, that's SSH root at the IP address. Cool, so you can see here, this is a brand new VM. We haven't done anything with it. But what DigitalOcean has done is gone ahead and configured, it's installed Redis, it's configured it, and gives you a, oh my gosh. Wow, live demos, right? Let me focus on just getting this in, and then we'll tackle it. OK. There we go. So let's see if Redis is running. It is, which is great. So that's actually the demo right there in that you can just fire up a droplet, Redis is running. I can go ahead and like install Ruby and show you that you can interact with like setting keys or getting keys or anything like that. But that's essentially as easy as it is to go ahead and create a droplet, have it configured with Redis. Yeah, any questions, any thoughts? Piece of cake, right? Cool. So very quick demo. I'm going to turn it over. We've got an actual speaker who's going to be spending the majority of time talking about far more interesting things and complex things, and probably more interesting for the people who've actually used Redis before as well. So I'll go ahead and turn it over at this point. Cool.
My name is Madhu. The easiest way to remember my name, if you're not an Indian, Madhu, right? Just say it fast. Don't say Madhu, right? So I've been a solutions architect with Redis Labs for about 2 years now. My background is I've been in security for about 10 years, database security for the longest time. I've been a DBA. So been in the database market for quite some time, covering Oracle, SAP, SQL Server, etc. So my idea here is to talk a little bit about Redis Labs, but I do need to know how many of you know Redis, or at least heard of Redis. Heard. OK, let's start this. No Redis. 1, 2, 3, 4, 5. Heard of Redis? OK, a lot. So from the people who heard of Redis, basic definition of Redis, what do you know? No SQL? Anybody else?
In-memory database with a lot more functionality than what I forgot the name of the other one,
Memcache. OK, close. Anybody else? OK, we'll talk a little bit about the use cases. I do want to ask a few things here. But so Redis is basically, you're absolutely right, as an in-memory data store. We always call it the data store, not a database, but because data store is more than just a database. The way I define Redis is the gateway drug. Most people start with caching. It makes things perform really fast, right? They love it. They start with caching. I heard somebody talk about caching here. Some of the caching examples are caching data, just instead of having to send the request all the way back to the database, right? If you have thousands and thousands and millions of rows or data that you actually want to retrieve from the database, it's going to be a problem, especially from a resource standpoint. Redis Labs is the home of Redis. So we basically sponsor the open source project, right? The guy who designed Redis, Salvatore Sanfilippo, anybody know him? Okay, oh, great. An Italian guy was working on a project in a telco company in Italy, was working with Oracle, but was not able to get the kind of performance he wanted. So that's when he actually started working on the Redis project. Redis stands for Remote Dictionary, right? So that's what happened in 2007, and it designed that. Redis Labs came into existence in 2011, and we've been supporting Redis since then. Right? We started with cloud offering. You could basically, it was a software as a service. We could go ahead and create a Redis infrastructure in Amazon, Heroku, Azure, SoftLayer, OpenStack, any of these. But what we realized about 2 years ago was the large adoption of Redis by enterprise environments, right? You're in New York, all the financials here, right? So they start adopting this, and most of these companies don't want to move to the cloud, at least 3 years ago. I know a lot of people want to now. So we actually created an on-prem product that supports Redis. So what is the difference? Anybody, any guess? Okay. So Ben showed you how to create a single Redis instance, right? It's very easy to create a Redis instance. You can basically install it. You have a configuration file. You can work with it. The challenge is when you start expanding or growing your Redis environment. Let's say it's more than a single instance. You want to have 5 instances, masters, slaves, or maybe deployed across multiple geographical locations. What do you do then? It has become a huge administrative overhead for a lot of large enterprises, and that's where Redis Labs comes into the picture, right? We have made this easy. We have made deployment and management Redis extremely easy, and I will talk about that. So these are the two products that we have. One is the Redis Cloud, which is both basically public and private, which is a shared infrastructure. You could basically say, okay, I want to create an instance in the cloud. I want to pay as you go. I want to start with 50 MB and then grow to 50 gigs. You can start to pay as you go. And then there's RCP, Redis Cloud Private, which is basically dedicated infrastructure depending on which environment you want to deploy this in. The RLEC is an on-prem environment, right? So if you have a data center, virtual machines, or bare metal servers, you can basically deploy the RLEC product. A couple of other things we have actually designed or redesigned how Redis works is running Redis on Flash. One of the biggest problems, at least a few years ago, was people wanting to run Redis but being limited by the cost of the memory, right? If I want to be able to run 100 gigs, 200 gigs, 300 gigs, 400 gigs, that was a problem. It was very expensive. And what that did was forced us to actually work with IBM. We actually started working with IBM on the P8 machines with the Capi card, where we started using Flash as an extension of RAM. So basically, you now have the ability to store maybe 10% of the data in memory and use the Flash to store the remaining 90% of the data. So that's what Redis on Flash does. Then now we have also extended that to Intel platforms. So we have tested this. You can actually go to redislabs.com and you can take a look at it. So the use cases. Excuse me. So we did talk a little bit about caching, right? Redis, as I said, as a gateway drug, people love to use it as a cache, but it's a lot more than that, right? Basic caching, that's what Memcache does, right? All you have is the ability to upload the data into the database or Memcache, a cache, if you will, and start accessing it from your application. That's all it can do. From a scalability standpoint, you have a problem. You may potentially have a problem if you're growing it, and then you can't do any kind of computation or analytics or anything like that. That's where Redis actually helps. Redis gives you different kinds of use cases besides caching. One is business applications. We have a lot of financial customers. I can't name them, especially since I'm being recorded, but a few of the credit card companies, right? Just to give you an example, how many of you have credit cards? Basic question, right? So, and do you have an app to manage your credit cards, right? So when you actually open the app, what happens? You can see all your transactions, maybe last 10 days, 15 days, 20 days, maybe several months. At least 2 of the credit card companies are using Redis Labs for that. All of that is going through Redis Labs, right? So that's why it's really fast. It gives you the ability to look at this data. Couple of other things. One of the things that a few credit card companies do is perform analytics. Okay, how many times has somebody used the card and spent between $50 and $100 in a specific geographical location, maybe near a zip code, 19720. So again, such reporting is actually going through Redis by a lot of these companies. And also, you all have investment portfolios, right? Yes? I won't ask that question. So a lot of times when you log in, you have day-to-day, the way your mutual funds or your stocks are changing. The financial companies are beginning to use Redis for that, right? Fast computation depending on how a given market is changing on a daily basis. That's the analytics. Time series data, we have financial customers using Redis for time series data, looking at how the stocks are changing, what's happening, and every other vertical is actually using that for time series data. Predict weather, right? How does it affect the agriculture? This was the last project I worked on. That's why it's very fresh in my memory, right? So they're basically using Redis to perform this time series analysis on how the weather is changing and how it's going to impact the agriculture stuff. Data ingestion. Anybody working on the infrastructure teams here? Only one. Okay, I'll just quickly cover it then. So one of the things that we have a lot of companies use it for is IoT companies, right? There's a lot of data coming in. Not necessarily, I don't necessarily want to perform any analysis. Or maybe I have a lot of devices in my data center, right? Maybe thousands of them. It's sending all of this data maybe into Splunk. So one of the problems is that Splunk may not be able to ingest all this data as fast as your devices are sending it. That's where Redis helps. Redis is able to ingest all of this data and then trickle it down to Splunk, right? So just to give you an example, that's one of the data ingesting use case. Social, you can actually look at online, redis.io. A lot of these social companies are using it. GeoSearch, anybody use? Just few? You guys live in New York. Come on now. They're using Redis. So again, caching, we did talk about it. I know a couple of people mentioned that. Again, it has a lot of these verticals. I don't want to get into it. Travel. So yeah, the other project I'm actually working on right now is travel. How many of you guys have gone on Expedia or Orbitz, looked for, or so a destination, departure and arrival, going through Redis? Just to give you an idea, the application that you can use, if you're doing certain kinds of search, right, even with the applications you're working in, you can absolutely use Redis for that. It's really, really fast. And if it's slow with Expedia, don't complain, please. Sorry. So what does Redis, what makes Redis so fast, right? So first is simplicity. Anybody work with databases? Okay, let me ask this question. What do you guys work on? I don't see too many hands going up. Infrastructure, dev, app dev? Okay, all right, so maybe this will help. So one of the biggest pain points when I used to code a while ago was trying to figure out what's the best way to write a given query. A given query, being a DBA, I know that you can write it a dozen different ways. Of that, maybe one is the most optimized one. And being a developer, I never cared. As long as my application worked, that's all that mattered to me, right? I didn't care about what was happening in the back end. So that was part of the problem. So, and the other thing is, when I was trying to design a database, all I had, the thing I had to do was always focus on trying to fit all the data I had in a table. That's it. That's all I had to work with. Everything had to be a table. Primary key, composite key, foreign key, etc. what Redis does is gives you the ability to use different data structures. As you can see, there are several different data structures. You have the strings, you have the lists, you have the sorted sets, you have the sets, things that you have used in the past as a developer, right? Whether it's Java, whether it's .NET, whether it's C, C++, all of these, you know of these different data structures. And that's the simplicity. Each one of these data structures has been designed to address a specific use case. Think about session management, right? If you're talking about session management, I can very easily use strings and hashes, right? I want to be able to look at the session. What did this user do? Okay, when they logged out, what was the last thing they did? So that when he logs back in, I can load them back, right? The pages he was looking at, the products he was looking at, maybe a certain portfolio things that he was looking at, I can just use that. If I want to update a specific field with maybe a person got married, right? I can just use a hash. I can do it with a single attribute. I don't need to write a complete query with a where statement, nothing. It's a simple command, right? So, questions? Okay. So these are some of the things, right? Each one, and like lists, I think was talking about pub/sub, right? In a similar fashion, you can implement queues with Redis, and lists is perfect to use to do that. You also have sorted sets. If you're talking about, I was talking about time series data, sorted sets, perfect. You have a lot of gaming companies that I've worked with in New York City who have actually used that, who are actually running on the DigitalOcean infrastructure. The second thing that Redis Labs, along with Salvatore, we have been working on is Redis Modules. One of the things, the limitations with Redis is that you have certain set of commands. If I want to develop an inverted index or a secondary index, I have to fit through the data structures I have. Sometimes, depending on what you're trying to do, how big is your use case, it could get a little complicated. That's where the modules will help. You can use the modules to create your own commands, to create your own structures, which in turn in the back end will use what Redis already offers, but this will be available with the next release. And performance. Take it with a pinch of salt, please. Everybody has a great slide about performance and benchmarks. So that's just, I didn't do that. That's what they did. That's what it is. But it does work great. So this was a 50 reads and 50 writes benchmark that was done against some of the competitors with Redis Labs. And that's what you actually see. The blocks are the total operations per second you had. Redis Labs delivered about 35,000 ops with about 71 millisecond latency on 2 servers. And in fact, I'll show you a demo. I can easily get about 1 million operations per second on two nodes in Amazon with Redis. Again, we just covered this. This is how you can actually use it, the different ways you can write your data structures. I'm going to skip through this. Questions? Okay. So we covered a little bit. Again, I just want to cover this time series data. You can use that for your tickers, have delivered really fast results, especially, and then you can also link that with some of the portfolio management if you're in the financial sector. If there's anything else, anything that relates with computing a sequence, right? 1, 2, 3, 4, what's the fast, something that's changing every few seconds, every second, you can use the time series data that Redis provides sorted sets. Session state, we covered this, but you can not only manage your sessions with Redis. What we have is we have a lot of customers moving the authentication from the backend database when the applications are coming in to Redis. So all the authentication is being maintained at the Redis level so that there's no traffic going all the way back to the database, reducing the load on your database servers. That's one way of doing the session management. You can also integrate that with your ASP.NET. It's very simple instead of using what ASP.NET does. So if you're an e-commerce company, you can take it one step further, right? So let's say I log in. There are certain products I look at. Imagine this. Amazon has 1 billion products. How many of you have actually gone through all the 1 billion products? How come when you log in, they know what are the products you may potentially like? Partly. But here's the thing, right? Maybe I don't log in for like next 2 months. Right? So what typically happens is when I log in, not only can I have a sliding expiry so that I can expire or time out the connection, what I can also do is every time I'm clicking on these products, remember one of the data structures was sets. I can actually start recording what are the different things I may be potentially interested in. So the next time I log in, and associate that with my user ID. So the next time I log in, you already know the potential products I like, what categories they belong to, and you can just show that as again, ads. If you're in ads, you can absolutely do that too. Okay? Fund calculations, we have, you guys in the financial sector, right? I know I'm focusing so much on financials here. Yes? No? Maybe? No? Okay. I'll skip that one. Analytics, so we covered performing data ingestion with Splunk. We also have customers performing analytics when the data is coming in, right? It may just be a transient state, but I can perform analytics as to what happened with the website, how many clicks have come in, how many products have been looked at. All of this maybe in the last one week or 10 days or 20 days or by a specific user. Or, for example, we have telecom companies performing analytics on every call you're making. All of that is actually, I won't name names, it starts with a V, but all of those calls are being recorded, right? In the sense that, okay, who did you call? How frequently do you call? Do you call local? Do you call East Coast to West Coast? Or do you call international, right? Those analytics actually helps them to target specific ad campaigns towards you, right? Maybe you may be interested in specific kinds of packages. So those are some of the analytics that you can actually do, and in a very fast manner. So what is Redis Labs? So on the left side, you actually see 3 gray nodes. These nodes for us is nothing but anything that's running an operating system. It could be a virtual machine. It could be something in the cloud. It could be a bare metal server. As long as it's running an operating system, that's all we care. We typically recommend an odd number of nodes, and that's for 2 reasons. One is for the quorum, to maintain the quorum. Second is to handle any split brain that may potentially happen, right? So you will never end up in a situation where you may potentially have a master both online trying to service the application. The installation itself takes you about 2 minutes on each node, literally. This install file is 10 MB. It takes you 2 minutes. You can automate that. You can have an entire cluster up and running in less than 10 minutes with the database created available for your application. Think about the possibilities, right? Especially if you have a microservices environment and you have different applications, how quickly you can actually do that. You can very quickly automate the whole process with a single click, like Ben was talking, and have it available to your application team. When you install, you have several components that actually get installed. That's a zero latency proxy, the cluster manager, the REST API, and the open source Redis. Right, the zero latency proxy has been developed in C. It's been developed by Redis Labs. It's owned by Redis Labs, fully supported by Redis Labs. It's a multi-threaded intelligent proxy that's basically acting as an interface between your application or the clients and the backend Redis database. And the idea is, if you go back to a few years ago, your typical infrastructure looked like your web servers, mid-tier application servers, which do connection pooling to the backend database server, right? Generic infrastructure. That's exactly what the proxy is doing. It's taking the role of an application or a mid-tier server, right? It has persistent connections to the backend Redis shards. It usually prefers to use a socket connections because they're faster than TCP connections, and that's what it does. The second thing about the proxy service itself is that it forces, when you shard, do you guys know what shard is? S-H-A-R-D? Okay. So shard is an instance of Redis. Have you guys worked with NoSQL at all? Anybody? Mongo, Cassandra, DataStax? So you guys know what shard is? Maybe. Okay. So it is basically an instance of Redis, right? So with Redis, the way it's a single-threaded application, that's the power. That's part of the reason why Redis gets its performance. It's really fast, right? The way you actually grow your Redis implementation is to shard the data. What it means is you're splitting the data or dividing it into 2 halves. You're not replicating it. You're not having 2 locations of the data. It's 50 and 50. And because it's single-threaded, each instance is actually using a separate core. And that's the job of the proxy. When you shard your database from 2 to 4 to 8 to 16, whatever may be the case, it'll make sure that each of those shards uses a separate core in the database. In the system. The second piece is a cluster manager. The cluster manager is, for all intents and purposes, is a set of processes that's actually helping you manage the entire database. Okay? The third piece is the REST API. The REST API is basically gives you the ability to interact with the entire Redis implementation, Redis management, the Redis labs. And we also provide a lot of metrics. We provide metrics at the cluster level, we provide metrics at the node level, we provide metrics at the database level and the node shard level. So the REST API will give you the ability to extract this data and actually populate in any event management tool that you may potentially have. Lastly, it's the open source Redis. The idea behind Redis Labs, as I had mentioned before, is not to move away from open source. We contribute a lot to the community edition. The idea is to actually take the open source and make it very easily deployable, extremely easy to manage, and very flexible in an enterprise environment. Because now we are seeing a lot of enterprise environments starting to use, easily going to upwards of 500 gigs of data being managed in Redis. And everything is in memory, by the way. Questions? Go ahead. I mean, it's okay. It's all right. It's still 9 o'clock. Yes, please.
Redis has its own database. Can it be used with, I mean, of course it does, but can it be used with other databases too?
Absolutely. All of them. Yes. So the good thing and the bad thing about Redis is that it makes things very easy. So there are no freely available plugins. You have to write how you want to translate the data. The good thing and bad thing about Redis is that it gives you so many data structures. It's not like a one-to-one mapping, right? It's not like I have a single string, I'm going to map it to a particular table, right? You need to know what you want to map it. But a lot of people have done that at the application level, and it's very easy to do. So the idea is it can work with a backend NoSQL. Redis is being used to speed things up with Mongo. It can work with an RDBMS, right? SQL Server, Oracle, Postgres, MySQL, or it can be used as a standalone database.
What do they use it mostly as? Say they're using this as, if it's not the main database, what do they use it mostly for? What do they use Redis for if it's not the main database? What is it used mostly for?
Caching, session data, computation, real-time analytics, all of that will require a backend database, right? Especially when you're talking about financial transactions where consistency needs to be immediate. Most people still go with RDBMS because Redis and most NoSQLs are eventually consistent. I can't lose a transaction. So I can't store the transaction in Redis, right? I can persist it, but in case that fails, it should not fail, but in case there's always that possibility. So in case that fails, then your application needs to go to the database. So in those cases, Redis is still not the chosen one. However, having said that, the next release will have immediate consistency. Go ahead.
Yeah, I want to know a little bit about like the solvers that you can kind of use for this. I saw like one slide. It's accessibly, it's like really helpful for ERM software.
Yes.
So in this case, what if you wanted to do like OR tools? You wanted to have operation research solvers in this case. So can Redis also handle like some of the analytics?
Absolutely. Oh yes, it's being used. That's why I was asking if infrastructure team here. But yes, a lot of customers are using that. You're also using for event messaging infrastructure between the different infrastructures you have. So yes, before you can think Redis does not work here, ask yourself, how can I use Redis here?
And like, does it have its own built-in solvers in this case, or you can use?
No, you'll have to write it. There's nothing built in with Redis, but it's very easy to write. Very easy to write, and I'll show you a quick code snippet. But basically, my code can be really, really small, maybe a 10-line code. That's how easy it is. Right? Go ahead. Sorry.
It's my understanding that Redis does not have a persistent store. So doesn't it by nature require you to have another database behind it?
Redis does have a persistent store. Redis does have a persistent store. Yes. Open source Redis does have a persistent store. Redis Labs does. One of the challenges with a persistent store is that when you're talking about high volume operations, real high performance, and being single threaded, it could limit your performance at any given time. If you're doing maybe writing 1 million writes to memory, right? And I have to record it at disk. At some point, you're going to peg your disk.
Does Redis have a journal?
Yes. So it does it in two different ways. So with Redis Labs, what we do is we actually replicate all the data over to the slave. You have a master and a slave shard running on two different nodes. It's an in-memory replication. Any write you do, any update you do, it immediately gets replicated over to the slave. And the slave starts writing to disk. That way you're not affecting the performance of the master itself and how it actually interacts with the application.
Well, if assuming you have any transaction integrity, you can't you can't respond to the user that you committed the transaction until the transaction.
It's asynchronous, and that's.
So the transaction can't be asynchronous. The transaction, a lot of systems do asynchronous replication between data center. I mean, that's a very standard thing. But in that transfer, you always have the risk of losing several seconds worth of data. Within a single server, you can't have, if I'm in Oracle or I'm in SQL Server, I'm in Postgres, every transaction doesn't get written to the database. It gets flushed to a journal, which is usually in a very high performance environment. And on IBM, on any cluster, it's actually in solid state memory. And it's when that's done, I can release the request of a transaction. I don't see that sort of hierarchy here.
Right. So what I mean by asynchronous is that replication between master and slave, and how your application talks to the master is asynchronous, right? You go update the master, but you're not getting a commit that it has been recorded. The challenge, that is part of the challenge that you have with Redis, because it's not, that's the way it is. If you're looking at performance, then you're just writing to master and it responds back. The slave will write it to disk right away. There are two different ways it stores. One is an AOF and RDB. Second one is an RDB. So till the time we have immediate consistency with a complete transaction, with the whole synchronous thing happen, there are certain places you cannot use Redis. It's simple. If the transaction is important for you, you have to make sure that it's committed before you respond back to the client. Then Redis is not what you should be doing.
In a couple of your examples, you indicated multiple access paths to the data. It was my understanding that Redis stored the data in a key value pair, probably hashing the key internally. How did you get multiple access paths to the data?
It's the data structures. You can define your data in different ways. It's all key value at the end of the day. But each data structure has been optimized to satisfy a certain use case, right? So if I define it as with a, let's say, an 8 set, it's going to be a hash. If I define it just as a set, it's going to be a string. If I define it as an SAD, it's going to be a set. So you'll have to figure out what your use case is, which is going to drive how you're going to define your data within Redis. That's the data structure path, but everything is still a key value. It is a key value store. Okay. Any other questions?
Yeah, what's the difference between your enterprise and open source?
All of the things I just covered. None of those things that you have at the top are available with open source. And more importantly, you don't have few things. High availability is something that you don't have so well defined that you can say I can have this without any outage with open source today. And again, I'm not putting it down. If you have a huge infrastructure, right, more than 500 gigs, maybe a terabyte, several terabytes, sometimes it could be a challenge. Scalability is what we do at Redis Labs. When you talk about scalability, is if I want to reshard the data, I could do it without any downtime to my application. And no management of any of your config files or anything like that. It's all just a UI, you just create it. It's all been optimized and orchestrated like a container type environment. And more importantly, you have support. Yes.
Do you have like some recommendations for the amount of RAM and other factors that you would want to recommend to someone based on their usage expectations? So like, let's say I'm expecting to have about a gig of stuff in the store. So therefore I should have 2 gig of RAM available or X.
So typically it is your data set size times 2 plus about 30% overage, just to be safe in case when you have spikes or you're doing heavy volume replication or your slave gets disconnected or you're doing snapshots, any of these, right? So that's what we normally recommend. But if it's when you're talking about 1 gig, but if you're doing a WAN deployment, right, across geographical locations with a huge data sets, then there's a different approach you can take.
Is that like recommendations that you guys publish on your site?
Yes. Okay. So real quick, this is the UI, and some of you who have worked with Redis will understand the pain you may actually go through, but this is the UI that we have available for Enterprise Redis. The cluster, this is all the entire different configurations that you have. It provides all the different metrics as an aggregate for your cluster. Again, this is primarily for infrastructure guys. Node 1, Node 2, Node 3, all the different ones deployed across different availability zones in Amazon. So you can basically turn on rack zone awareness with Enterprise Redis, so that should one of your ESX hosts fail or one of the availability zones fail, you're automatically failing over, and it's providing high availability for your application. Yes?
That's not showing on the screen.
Oh, sorry. Thanks for letting me know. Okay. Sorry, let me go back. So that's the cluster piece. I was just talking about all the different metrics. This is the nodes I was talking about, node 1, node 2, node 3, n+1. Anytime you have, it's going to show here how they're performing. You can click on any one of these, and you can look at how each one of these nodes is performing in terms of memory, in terms of CPU, in terms of incoming traffic, outgoing traffic, etc.
Most of your examples, you're looking at these huge enterprise clusters. Some of us have smaller applications.
How small?
I haven't sized it, but say, I don't know, a few tens of, I don't know, less than a couple.
So yeah. So,
but the question is a little different. Is what notice with Redis? When I've been looking at Redis, I've been mainly saying is it's a key value in memory store. Since 99% of my access is read only, that I basically end up caching what's in the, instead of going to using let Postgres cache what it can do in its limited cache, by using Redis in between, I'm effectively caching everything and providing a high, a low latency response to those sort of axes. What does that mean? That was a question. Would that be a correct application use case?
yeah, absolutely. That's the basic caching use case.
So there's a big performance improvement even if I don't need to go to 10, 11 nodes.
Oh, no. So again, that's why I asked you. I'm talking about, and if you have a 1 gig, say, we do have customers who use 1 gig and they have a requirement that I have to put it on-prem. It's they cannot afford a downtime, right? And they need support, or they need to be able to scale from maybe, depending on operations per second. Even with 1 gig, I may end up having 2 or 4 shards, depending on what you're trying to do. It's very possible, right? So in that situation, they end up going with Enterprise Redis. If it's not that critical, a lot of people with 1 gig, they just use open source, and there's nothing wrong with open source, right? It depends. So, and we have, for example, Twitter, right? Part of Twitter is with Redis Labs, part of it, but their majority of the implementation started way before Redis Labs, right? They maintain their own petabytes of data. So it's possible. Yeah.
How much does the enterprise cost?
How much the
Enterprise cost?
It depends on the shards. How many shards? It's priced per shard.
How many can it be?
What's that?
How many can it be?
Depends. It depends what your data set size is and what your operations per second requirement is, right?
1, 2, 3, 5.
What is 1, 2, 3, 5?
How many shards minimum?
2. If you want, no, you can have 1. If you want high availability, it's going to be 2. 1 master and 1 slave on a 3-node cluster. That's fine. You could be running on a 2 gig.
That not be open source at all, huh?
What?
Shards.
You can.
Why do you need enterprise for?
High availability. And infrastructure. If you're not an infrastructure guy, you want to do it yourself, it's very easy. Yeah, you're fine. But when you're talking about a infrastructure team that has to manage not just your shards and who's going to be responsible if it goes down, then
I was thinking another way to possibly look at when you go enterprise and when you don't If you had a $10 million IT budget, you probably bought enterprise. If you got a $100,000 IT budget, you probably didn't.
No, we actually have a lot of people do that, but you're right now. So that's where the Redis Cloud actually helps. A lot of customers go with Redis Cloud. It's because it's pay as you go, and it's pay. We have anything less than, I think, 1 gig is free on Redis Cloud. So a lot of customers just go there. If it's less than 1 gig or 5 gig, I don't remember, but you can just go and create an instance, and you can start using it free of cost. And it is supported, by the way.
Where do you host Redis Cloud?
Depends. We do have it in Amazon. We do have it in Azure. So you have the choice. You can select, and it will be co-located. It will be a shared environment.
You don't have it in DigitalOcean, how dare you?
That's why I'm here. That's why I'm here. Actually, DigitalOcean, I don't want to steal the marketing team's thunder, but yeah, you'll hear something soon. That's why they made me drive for 3 hours. So the nodes, we talked about this, right? And then the database, it's extremely simple. We do support Memcache, so we have a lot of customers moving from Memcache, by the way. So creating a database is extremely simple. It is a one, you can define your memory limit and you activate, right? That's all it takes to create a database. And that can be automated, especially in a microservices environment. You can very easily do this. If you have to define anything else in terms of high availability, right? I just go ahead and define replication. It creates a master and a slave, and it'll always create the slave on a different node. If you have more than 3 nodes, you can turn on what we call rack zone awareness, so it'll always be on a different node on a different rack. It could be a separate ESX server, it could be a separate availability zone, whatever may be the case. And creating a clustering, and this, I think, back to your question, yes, you can create shards, but it's not this simple, right? I can create 2 shards just like that, that's it, and it can be automated.
No, I'm sorry, I was confused. The enterprise is actually your hosted version, that's what it is, right?
It is supported and with a wrapper. It's still open source in the behind.
Other licenses or something?
No.
You guys take care of everything, basically.
Yes, and we actually do develop a lot with the open source too, right? So that's all it takes to create shards, right? You can very easily grow this while the application is still accessing it. Questions? Yes.
So the custom hashing, how do you do it?
So we use regexes here. So typically with the, traditionally what people have done is you can do it on the client side using hashtags, right? Which will force specific keys to go on specific shards, right? But if you have a lot of applications, maybe there'll always be a scaling issue. So what you can do here is basically define a similar concept. Instead of using the hashtags, translate that to a regex and define it in the console itself. So your application doesn't have to do anything. It still sends the same data, and the proxy will basically apply the hashing algorithm on the key and put it in the necessary, the partition or the shard that it belongs to. Yes?
So you're saying Redis will use regex, Redis and?
Redis Labs.
So the application doesn't have to manage.
Yes, that is correct. You don't have to do it. No client-side sharding required, first of all, right? So you don't have to manage or generate a hash slot on the client side and then say, okay, which shard does it need to go to? Here, all you will see is a single endpoint, right? That's all your application will know. Doesn't matter how many shards you have in the backend, 2, 4, 8, 20, 100, doesn't matter, right? You could go from 20 to 100, you still don't have any application downtime. No application reconfiguration. All you're doing is accessing the URL, the endpoint. That's your connection string, right? Host and port. That's all you're doing. No client-side sharding, no clustering, nothing. You don't have to do that. Any other questions? Yes.
What kind of features do you guys see in the future as you're continuing to develop, and what kind of backwards compatibility should I be aware of as I'm developing integrations for my product?
So the biggest thing that we are working on right now is to actually develop the whole modules section. If you go to redismodules.com, you'll see all the different things, right? It'll soon, the vision is to make that something very similar to an app store, right? So we certify things, and we actually had a hackathon recently about people trying to develop different modules, right? So the idea is to actually certify them and start supporting them, right? So that is one of the biggest things we are working on right now. The second thing is we are also trying to solve the challenge of master-to-master replication, which is a big challenge. And if you've used Redis a lot, that is one single big challenge people have faced, especially when you're trying to replicate it across multiple data centers, right? It's a one-way replication. So that's the other thing that we are actually solving. The third thing we are doing is for these huge telco customers where you have huge network payloads, right? And several million connections coming in. If you have seen this, right, you have an active and a passive proxy, a single node could be a bottleneck, potentially, right? So we are developing the multi-proxy option where it goes in a round-robin fashion, can take several millions of connections coming in. So those are the three big ones that we are working on right now for the next 6 months. Integration, oh yeah. So far we have continued to support till 2.6, and the idea is to at least have the past 3 or 4 versions continue to support.
You guys have sort of a time frame that
2 versions a year. Both are major versions, so that's what we're trying to stick to. And so far, we started in 2011. We still support the version we released in 2011. So the idea is to be able to support anywhere between 3 and 5 years before we expire the product. Now, one good thing we have is an in-place upgrade. So there's no downtime. You can basically, what we provide is executables that you can just install. It upgrades the binaries. And you can go in and say, I want to upgrade the database, right? So it'll automatically fail over to the slave while the application is still working. And the reason you won't have a downtime with the application is because the application is connected to the proxy and not directly to the shard. So the proxy and the cluster manager in tandem will manage that connection without creating any downtime. It upgrades the old master, fails back, and upgrades the slave. So, yeah.
Well, you consider it a lot of products are now doing this LTS model, where you have a 2-year lock on 5 years of support, but 2 years of a lock on your main version.
No. You're free to do. No, we're not doing it like that. Yes?
I'm working on an API similar to the back end of TaskRabbit. I was wondering if I could use Lattice to cache those transactions. Would it kind of speed up caching those transactions?
Maybe. It's funny. I seen that question. I saw the smirk on the face right when you asked me. Go ahead. Yeah.
So 2 questions. One is you were talking about automation. Is there like a command line tool or API that we can just use to create this?
Yes, the API. We do provide the API that will help you do all of the things that I just showed you through the UI. And there are certain tools at the command line, which we call Redis Labs admin, that also provides you the ability to fail these shards over. Because if you see, the UI doesn't give you the ability to fail the shards over. The idea is this is just to go create and manage, right? Failing over shards or migrating shards from one node to the other without now, all that is admin. That's what we consider. So you have APIs to do that too. Yes.
And the other part is, let's say I want to process the slave to a database somewhere. Will I be able to log in here and then download the actual database?
Yes, you have the ability to export from here, export the data, and take the periodic backups if you want to. And you also can persist the data from here. So 2 things, right? When you're persisting the data, you're actually writing it to disk. And the only time you ever use that is when you lost the entire cluster. You have to reboot. You're doing an entire reboot. It needs to load from the memory, load from the disk. Then you also have the periodic backups that you can actually take and store it anywhere you want, which was basic, the entire database. And ad hoc export. If you want to be able to export and import it somewhere, you could do this. All available. Any other questions? Yep.
2 questions, real quick. What is the networking model in terms of security for those channels? Is the idea that you'll be connecting to some sort of virtual or private channel, or is it across?
To the console, you mean, or to Redis?
Your Redis instance. So are you going? Is it secured?
You mean this? This one, not this one.
Right.
This one. So it still uses the same concept that you have with Redis. You can use an auth password to connect to the instance. That doesn't change. However, you can define SSL between your application and the Redis instance with your application. That's one way. The other way is you can define S-tunnel between your application servers and the Redis servers. Second way. Third way is you can define IPsec if you want to. That's also possible. And going back to one of the things I failed to mention, we are actually changing one of the challenges when we're working with a lot of financial customers is you don't have two-factor authentication or a username password authentication with Redis. And that's the core of the product. You just have auth, right? So one of the things we are doing is by way of modules, trying to implement a username password for authenticating to Redis. So that way you can actually segregate different applications, right? Each one will have its own username password. That becomes, from a compliance standpoint, it just becomes easy for a lot of teams. So that's part of, I forgot that. Yeah, that's part of the Redis modules we have developed. There's one that's already available. It's again not to be tested in production environments, but you can go to redismodules.com and see it. Yes.
What is the time or anything that we just config? Most of them allowed can be changed from here, like time of failure between the master and the.
So no, those are more like admin activity. So you'll have to do it from the command prompt. So not from here, right? This is strictly configuring, setting up alerts, setting up thresholds around your database. If something goes wrong, you can do that. So there's an RL admin utility and RL util that's available at the command prompt of the host itself, right? Where it's running, you can do what you need to do. So just to finish that, it's highly optimized. And so far, I've had to, in the last 2 years, I've had to change that for only 2 customers.
So what's the default setting?
It's 2 seconds.
You've mentioned analytics a number of times. I'm just kind of curious what a high-level explanation is about how you implement that. Is it something where, as the data is coming in, the Redis instance is...
You're putting the data according to a certain data structure, right? So you're ingesting the data in a certain way. You're processing it according to the structure you want, right? It could be set. It could be a combination of hash, set, or whatever you're doing, right? Then you do have another application that's actually performing the analytics. It's not the same thing, right? Where you're actually looking at this data, you have real-time data that you can take a look at and say, this is what is happening, whatever you want to do at that point.
So the application that would be performing that would be external from capturing the data.
Yes, yes, yes.
And then analyzing it, put
Yes.
it in the same document.
Yes.
And how much RAM is this capable of processing?
We have it deployed in environments that's close to a petabyte right now with 65 nodes. Yep.
A lot of the database systems have their own in-memory caching and EMC clusters and stuff. How does it compare to those front ends to the actual caching of a high-end commercial database like a DB2 Oracle?
It's a good question. I couldn't figure that out yet. It's an RDBMS. First thing is what you're trying to do, right? Are you trying to deal with a NoSQL, unstructured data for performance reasons, or do you want to maintain that? The second thing, what I've understood, and I haven't researched this yet, I've been away from that world for a little bit, is the amount of memory you can actually use, right, in the memory for storing all of this data, right? I believe some give you the ability to store everything, and some like SQL Server give you the ability to store only a limited amount of data in memory. With Redis, everything's in memory, and it's been written to be accessed and returned to in memory. So I haven't tested the performance myself yet, so I can't speak too much about that. Okay, if there's nothing else, any other questions, I can take it offline. I'm going to sign off. Thank you, guys.
Thank you again to Madhu. That was incredible. and thank you all for coming to our last meetup of 2016. Hopefully it was a good one for you. And DigitalOcean is a huge advocate for the open source community, and we're really looking forward to collaborating on more open source developer tools for our future meetups in 2017. I also wanted to mention that DigitalOcean does write a lot of tutorials, and we have some specifically dedicated to Redis and Redis Labs. So if you go to do.co/Redis, there's a whole list of different Redis tutorials there. Well, we have a short link, and so it's do.co/Redis, and all of it's right there. All right, so without further ado, this isn't from ThinkGeek. This is actually from our swag store. This is Sammy the shark. Sammy is our mascot. And these are Sammy slippers. On top of me being the event specialist here at DigitalOcean, I also handle our swag production. And this was the first unique piece that I got to work with our design team on. So something I'm pretty happy with. The way that it's incorporated into DigitalOcean is that part of our onboarding process for every new hire, part of you go through a checklist, fill out your W-9, and then you also choose slippers. And we have Free Your Feet Fridays where you get to wear slippers around the office. And so this is a way to bring our user culture into our employee culture. So these are Sammy slippers. And for those that don't want it, we also have a swag shop that you can purchase them, and it's just store.digitalocean.com. Then, these are from ThinkGeek. So we have a Star Trek clock. Then, how many of you are familiar with Fallout, the video game? That's my favorite video game of all time. I walked into ThinkGeek. By the way, there's a ThinkGeek store on 33rd and Broadway. Yes. It's I walked in, I was like, ah! So tons of Fallout stuff. I had to choose one. So I got something that you could use, a little Fallout book. Then got an R2D2 USB wall charger. We got DC Comics heroin scarf. Heroin? Yes, heroin. We have Jin Urso bobblehead.
Who would you rather be Superman or Spider-Man?
And then this is pretty cool. I actually haven't played, but it's a Pokemon mug with the spinner.
Wait, what?
It's a Pokemon coffee mug, but the spinner's there, and you can spin it. I know which one's going first. So the way that works, I'm going to draw a raffle, and then you can just come and pick whatever one you want. So there is no grand prize. It's just first come, first serve. Here we go. We have 379, 370. 379, 370. Woo! All right, checks out. So whatever you want. All right, thank you. All right, here we go. We have 379, 369. All right. 379 380. 380. Woo! My man. All right, now I know for next time, all valid stuff. Good, good. All right, we got 379 362. 379 362. All right, snooze. Three 391. There you go, buddy.
So you can make sure.
Got it? Nice. Got to put batteries in it, though. All right. 379 405. 379 405. All right. Good job. All right. They're all stuck together, so it's hard to get one. 379 407. 407. Nope. Three 383. All right, come on up. You're welcome. Three 381. All right. You can wear it. You can give it a lady your choice. Whatever you. Beautiful. Gorgeous, darling. All right. Thank you again for coming. You can stay till 9. There's still plenty of food, drinks, and I'll have the music going until 2017.